Hi, everybody. It's so great to be here. Thank you so much to the organizers of TiE for welcoming me to the stage. I start all of my presentations with a personal story. And this is a personal story of myself growing up as a child. I have an identical twin brother, so I'm the one on the left-hand side. When, this photo was taken when we were young, and a few years after this photo was taken, the country I was living in Iran, and I lived in Tehran, in the capital, we went through a revolution, and a war started with the neighboring country of Iraq. So I actually had to spend the early years of my childhood spending every single night in a basement holding my ears when our city was getting bombed, hoping that our house wouldn't be hit by the bombs. And every morning we'd wake up and go to the rooftops to see which of our neighbors were still standing. It was basically the worst place to grow up as a child. But the arc of my life changed one day when my dad brought home a magical gift. He brought us a Commodore 64 computer, but this actually wasn't the magical gift because this Commodore 64 didn't have any apps or games or programs on it. He gave us, however, a book and basically said, this book will teach you how to code, and if you can learn how to write great code, you can make your own apps, make your own games. And this really sparked my imagination and helped me realize, even at an early age, that with computer science and coding, even living in a war-torn country, you can create something out of nothing. That got me started, and by the time my family immigrated to America, I was so good as a coder myself that I started working at tech companies even when I was still underage. So I was getting paid under the table to help make money to pay my way through school and university. And I'm now living what I consider to be the American dream. The success I've had in the tech industry really makes me a poster child of the American dream, which I think of as not just an American idea. It's the global idea that if you have hopes and dreams, if you work hard enough and work smart enough, you can accomplish anything. But the American dream has really changed. Initially, the American dream used to be about going out west and building a log cabin or participating in the gold rush, trying to find gold in rivers. But these days, the American dream is really about opportunity, and it's really intertwined with technology. Now, when we think about the American dream, there's a real question we should ask about, which is, what does the American dream look like for the next 20, 30 years, for our future, for our children? Think about the top jobs that are available in this country or in other countries. About 3 million Americans work as cashiers in stores at a time when Walmart, McDonald's, Amazon, all the largest retailers are working on technology to eliminate the use of cashiers. 3 million Americans work as truck drivers when every major trucking company is working on self-driving trucks. There's 3 million food workers in America, while there's technologists building robots that can automatically make food for fast food restaurants. There's about 3 million manufacturers on production lines, and they also are working on manufacturing at a time when every major manufacturer's most important hire is software engineers to automate that work. And really, we're in a time, as you all know, where technology is going to dramatically change our workforce and automate the jobs of today. If you think about how many jobs are currently in our workforce, predictions by Forrester say that 16% of these jobs will be automated just in the next 8 years. PricewaterhouseCoopers says that a third of the workforce will be replaced by computers or some form of technology in just 15 years. And McKinsey says that almost 50% or 60% of our workforce is going to be automated by the middle of the century. That's half of all jobs being replaced and being replaced by something else. And when you think about this, most people think, oh, this is going to be the truck drivers or the laborers, the lower wage jobs. But even high-paid jobs are going to start getting automated. If you work as a patent attorney, a lot of what you're doing is scanning through old patents to find patterns that match a new invention. That work might be much easier to do for a computer that can instantly search through all sorts of patents using machine learning technology. If you work as a radiologist, already today, technology can do a better job of recognizing most diseases on a radiology report than a human can. And it's just a matter of time before that starts rolling its way out into hospitals globally. As a side note, if any of your children are studying to become radiologists, you might want to tell them to switch careers now, because it's a career that is likely going to end in the next 5 to 10 years. But when you think about radiologists, this really brings up the double-edged sword of technology. When you think about technology, if you look at these two radiology reports, which one of them has pneumonia, which one doesn't, I can't tell. You need to either be a radiology expert or a computer, but computers can do that job better, and that doesn't just put radiologists out of work, it also helps us be healthier. And this is why I say technology is a double-edged sword. I love to tell a story about this boy named Joshua. Joshua, when he was this age, went to a family vacation in Florida, and when he came back, he had a really bad headache, and he told his mom that, "Mommy, I'm sick." And so Mommy took him to the doctor, and the doctor, looked in his ear and looked in his eye and looked in his mouth and said, "Why don't you send him home and rest a little bit? I can't tell what's going on." 2 days later, Joshua was in a coma, and he was sent to the hospital, and they spent 1 month of doing tests on him, continuously trying to figure out why is he in a coma. They spent $2 million on these tests, and the doctors couldn't figure it out. When they were basically at the point of giving up on Joshua and saying, "All right, well, let's just pull the plug," a researcher at UCSF said, "Can you give us a blood sample from Joshua and let us see if our computer scientists can figure it out?" So they took a blood sample from Joshua, ran it through a gene sequencer, looked at all the DNA of what was inside his blood, and then ran some code to separate out the human DNA from the foreign DNA, immediately pinpointed what was the foreign DNA, what kind of bacteria it was, prescribed a medicine, and within 24 hours, Joshua was walking out of the hospital. They could have skipped a month of tests and millions of dollars of costs if they'd just used computers to identify the problem first. And this shows you how much computers can not only impact our workforce by taking away jobs, but make us live healthier, more bountiful lives. When you think about something like self-driving cars, people talk about truck drivers losing their jobs, but we should also think about all the millions of injuries and the billions of dollars spent in car accidents and the lives lost that might be saved if we have cars that can drive themselves. And when you think of self-driving cars, another more interesting idea is self-driving tractors. The future of tractors won't not only drive themselves, but they'll have the ability to scan the field as they're driving over crops, looking at individual plants, giving personalized treatment to individual plants to increase the yield of our crops in our agriculture. Thinking beyond computer vision, looking at the world of 3D printing, just last month, a company announced a 3D printer for printing houses. This is a house that was 3D printed in 24 hours for only $10,000 of cost. At a time when over 1 billion people around the world lack housing, we can finally build cheap, affordable housing at high scale and quite quickly using technology. When you think about these examples, and then you think about what are the jobs and the change of the workforce, you realize the more automation we add doesn't just take away jobs, it increases productivity. And this is a story that's been told throughout human history. If you think about the loom, when the loom was invented, everybody was saying, "Oh my God, this is going to take away jobs. Everybody who's a weaver will be out of work." And indeed, all the weavers in the world, almost all of them, are now out of work, but we all get to wear cheap clothing that's much more affordable. When the car was invented, people started saying that, "Oh my God, everybody who works in a stable is going to be out of work. All the people who work on making horseshoes are going to be out of work." The entire horse-related transportation industry had changed, but an entire new industry came about, not only the automobile industry, but the industry of building highways and the changes to our cities, restaurants, hotels, shopping malls, all these things basically sprung up because of the invention of the automobile. When modern farming equipment was created, just in the last 100 years, 50% of all jobs in America have been automated by modern industrial farming. About 100 years ago, half of Americans worked on a farm, and now it's under 5%. So we already, as a country, have gone through a change where half of all jobs got automated. It's not something that's only in the distance past. It's something that we can handle with. So really, the trillion-dollar question is, if half the jobs in America are going to be replaced by technology, what are the jobs of the future going to be, and how do we prepare our children for those jobs? Now, you don't need a crystal ball to imagine what the jobs of the future are going to be. You just need to look back 15 years. If you look at 15 years ago and compare it to today, and look at the difference in the jobs from between now and then, you see this slice at the top, the change from 2002 to 2016 of highly digital jobs, compared to moderately digital jobs, compared to totally non-digital jobs. It's obvious that digital technology is changing our workforce. And now if you imagine 15 years from now, the green and the gray parts of the graph are going to completely fill that chart. So a student that starts kindergarten today, graduating college in 16 years, that's what we need to prepare them for. Now, even if you don't look 16 years into the future, if you look today, computing jobs are the #1 source of all new wages in America. And this isn't just about hiring software engineers in Silicon Valley. It turns out that 91% of software jobs are outside of Silicon Valley, and 2/3 of them are outside of the tech companies. They're at manufacturing companies, entertainment companies, telecommunications companies, at banks. Computing has become the fastest growing, highest paying, and largest sector of new jobs. So when you think about opportunity in a time of automation, the answer is the future of our workforce is in technology. This is also important when you think about diversity of the tech workforce, which is a topic that's near and dear to my heart. And especially when you envision what the jobs of the future will be like, we're really talking about diversity of the entire future workforce. Now, at code.org, we think about diversity as something that isn't just in the workforce, it starts in the education pipeline. The same picture and the lack of diversity you see in the tech workforce occurs in the university computer science departments and also in high schools. And the K through 12 system is what we think about. Now, the question I asked when I started code.org as I saw these trends was, what's the role of education in all this? How do we change the education system to prepare the workforce of the future? When you think about education in America and in most countries, all of the education debates that happen are arguments about how we teach. If you look at any kind of policy argument or debate about education, they talk about charter schools versus regular schools versus vouchers, about labor unions fighting about longer school days or smaller classroom sizes or more testing or less testing. Everybody's debating how we teach. There's not enough of a discussion about what we teach. We need to be preparing our children for the jobs of the future, not the jobs of the past. Now, since I wear a hat that talks about coding, people assume that I'm talking about teaching kids coding, but it is about computer science. When I went to school, every kid would learn about the digestive system, about how electricity lights a basic circuit, or about the Pythagorean theorem. And in these days, it's just as foundational for students to learn what an algorithm is or how the internet works. And when you think about this, this isn't just about teaching coding, it's about teaching computer science, which is much broader than that. It includes things like computer programming, computational thinking, data science, networking, cybersecurity, robotics, and artificial intelligence. This field of study is something that needs to be taught in our school system. And the vision of code.org is that every student in every school should have the opportunity to learn computer science, globally, not just in America. Now, this is a vision that if we address properly, can expand opportunity and equality to people everywhere, and again, not just to the white men that are dominating the tech industry, but to girls just as much as boys. To get this vision started, we started a movement called the Hour of Code. And the Hour of Code has been a grassroots movement fueled by hundreds of partners and hundreds of thousands of teachers working in every single country on the planet to basically teach only just 1 hour of coding and computer science in classrooms. And I have a short video that talks about the impact of the Hour of Code. If you bear with me.
Okay, now you're gonna press run. This is so cool!
Hour of Code.
The Hour of Code. Todo lo pueden hacer.
Ya programmi ako.
Your teacher says you guys are into it.
We are. It's very awesome.
Code.org has partnered with 30 public school districts across the country, including New York, Chicago, and Denver, to provide lessons in teacher training and writing.
The largest education events in history.
Organizers set what they called an ambitious goal of reaching 10 million students this week. Almost 15 million signed up.
This week, I'm proud to join the students, teachers, businesses, and nonprofit organizations taking new steps to support computer science in America's schools.
I
I ran an hour of code that's easy to do.
I got it. They've been so excited about it.
Oh my gosh, it's working. I did it right.
They don't even have to be a computer science engineer. Maybe they want to do something else. But in our world, this is going to be the basis for everything that we do.
Semicolon.
When you're building a program, you have to think outside of the box.
If you can change technology, you can change the world.
I challenge girls in every single country to learn 1 hour of code.
Every district should do, every district can do it.
Please help us get the hour of code to every school and every classroom and every child.
And my school's doing it.
So when that video was made, the hour of code was at around 100 million students having tried it. We've now reached almost 600 million students for something that has only just started 4 years ago, which has been an unbelievable success of the education system globally. Now, the hour of code is not enough to learn anything, really. You don't teach an hour of math or an hour of English. You learn these things for a lifetime. But what the hour of code does is it changes people's mindset, that teaches them that my school can teach this, my kids can learn this. You know, an 8-year-old can start learning computer science. Having started this movement, we're now at the point where 90% of their parents want their children to study computer science. 75% of Americans believe computer science is cool in a way that it wasn't 10 years ago. Students themselves rank computer science as their favorite subject behind only the arts and dance. And yet, the majority of schools don't teach computer science. This is a problem that we need to solve, and the question is, how do we actually change the global education system? What Code.org does to change the education system is 4 things. The first is we've created curriculum and workshops for the teachers in our schools to learn how to teach computer science. Then we've made a platform that makes learning really accessible. Our platform starts in elementary school, where you drag and drop blocks to do coding, and the blocks that you drag and drop are moving around fun things like the Angry Birds or R2-D2 from Star Wars. And this platform graduates all the way to high school, into high school AP computer science, where you can type JavaScript and you click a button, the blocks can change magically into JavaScript, where you can type code and you can make real apps and even control physical computing with robots and so on. This platform is designed to make it easy for any teacher to teach computer science. And what this unlocks is the creativity in students. Students can use code to make fun stuff. When a student makes an art that was made by an 8-year-old, or this game that was made by a 12-year-old, or this app that was made by 2 15-year-old girls, creating things in school is just innately fun. It's so much better than answering multiple choice questions on an exam. It's something you can take home and show your mom and dad, or to show off to your friends. Now, besides making a platform and training teachers, we're changing district, state, and federal policies. Code.org is working with leaders at all levels, all the way up to the national government, to get computer science to be part of the curriculum. To give an example of this, I want to give the story of the Oakland School District just across the water from where we are. You know, when you live in the San Francisco Bay Area, we're basically in the heartland of tech, where all of the largest companies in the entire planet are created. And across the water is Oakland, one of the poorer cities in our country, with an incredibly diverse population. And 2 years ago, when we started working in Oakland, not a single school in Oakland taught computer science. One teacher who you see up here, Claire Choral, she basically was a math teacher. She taught herself coding and began teaching a class at Oakland. And that year, her AP class had about 8 African-American students in it. And she found out that her 8 African-American students represented roughly 10% of the entire state of California among African-Americans learning computer science. And then she realized that's a problem. We need to fix this. We need to teach computer science in every school. Working together with Code.org, we trained 1 teacher in every school and gave them our curriculum platform. And in 1 year, every school in Oakland now teaches computer science. And in fact, they started as early as elementary school. In 9th grade, it's become a requirement in every school a requirement for every student in Oakland public schools to learn computer science. It's being taught by math teachers, science teachers, history teachers, art teachers, teachers who themselves don't have a background in coding and computer science. But because of the training and the curriculum, they're not only teaching computer science, they're helping kids pass the AP exam. And in fact, in the very first year, the Advanced Placement College AP exam in computer science in Oakland was not only the most popular exam, it was the third most passed exam, and students did better on the computer science exam than on math, history, English, or science, even though their teachers were math, English, history, or science teachers. And this shows the power of what a school system can do when it decides to teach a new field of topic. Now, Oakland isn't alone. This story is actually happening all around the country. It's happening in every major city in America. We've now created what has become the most bipartisan and fastest spreading movement in education. I like to joke that that's a picture of teachers doing the Hour of Code, but it's actually a rock concert. However, if you look at the number of people in that photo, the number of teachers that have engaged with Code.org in just the last 4 years is over 1,000 times what you see in that photo. And that's the value and the power of a movement that spreads by word of mouth. The Advanced Placement College level AP exam in high schools is the fastest growing exam in America right now. The graphs here on the left, you see girls who are taking the AP exam, and on the right, you see underrepresented minorities. These are the groups that are most underrepresented in technology, and the participation in computer science in high schools is skyrocketing because of the schools that have decided to teach computer science the way Oakland has. At Code.org, we now have over 27 million students on our platform. That's roughly a quarter of all of America's students. Almost half of them are girls. Almost half of them are underrepresented minorities. And almost half of them are too poor to afford their own lunch, and yet they're learning coding and computer science in America's public schools. This started with the individual teacher that decided, I want to teach this in my own classroom, and now almost 1 million teachers have joined that group. It's 850,000 teachers. It's spread to entire schools, and almost half the schools in the United States are now teaching computer science. Entire school districts got on board. Over 200 of the largest school districts in America have now changed their curriculum to teach computer science. And then entire states are now doing it. 43 states have changed policies since we started our work just 4.5 years ago. And then at the national level, 25 countries in the last 5 years have decided to add computer science to the national curriculum. This pace of growth is truly unprecedented in education, and it's a life dream for me, frankly, to be able to even talk about this, to say that this has actually happened. Thank you very much. What's also amazing is that of the students that are learning computer science in schools, 70% of them want to study it beyond going into graduation, which means the students themselves are enjoying this course. But still, despite all this progress, most schools still don't teach computer science. We're just about at 50% in this country. Globally, it's about 10% of schools that teach computer science. We have a lot of work to do. So if you want to help, please join the movement. You can visit code.org, and there's a button for Help Us. And if you are a parent, please ask your children's school to teach computer science. And I lastly want to close by saying, everything that we've done at Code.org is really thanks to the teachers. There's over 800,000 teachers on Code.org. It's really them working in the classroom that is changing the face of education for the betterment of all of our children globally. And lastly, the generous donors who support Code.org, without their work, we wouldn't be here. The tech companies get a lot of heat these days for not having a diverse enough workforce and other things that it's popular to hate the tech industry these days, but the work that they're doing in terms of funding us to support this change of education for our students is a huge part of what's going to prepare our children for the future and make the world a better place. So thank you very much, and enjoy the rest of the conference.